In this video, we're going to talk about how to graph square root functions and identify key features. So the square root parent function is given to us by the equation f of x equals the square root of x. So you can use a table of values or Desmos to help you graph the square root parent function. So if we were going to graph this by hand, we would take all of these x values that are given and plug them into the function f of x. So for example, for x equals 0, we would do the square root of 0, which is equal to 0. So that would give us our first value. So we can actually plot the point 0, 0 on our graph. If you would prefer to use Desmos, you can just go ahead and type in your function. So you do f of x equals, and then to get the square root, you can type sqrt on your computer and it'll automatically create a square root sign. If you don't like to do it that way, you can go down here to the bottom left and open the keypad. Then you can click this square root button to get the square root also. So there's two ways to do this. And then make sure that you put the x under the square root. And then what we can do here is we can see the graph, right? If we want to get the tables of values, you're just going to click up here on Edit List, and then you can see there's a little table icon right here. So if we click on that, it's going to create a table for us. Okay, so we're looking for the values at 1. So it tells us at 1 we have value of 1. So we'll go ahead and write that down. And we also need the values of 4 and 9. Since those are not in our table, we're just going to type those in here, and then it'll automatically tell us what those y values are. So at 4, the value of the function is 2, and then at 9, the value of the function is 3. So I'm going to go ahead and plot these points on my graph. So I have 1, 1, 4, 2, and 9, 3. Okay, and then we can connect these points to form the graph of the square root parent function. You can always use Desmos to double check and make sure that it does look like the graph that Desmos created. So what we do when we graph square root functions is we want to think about some key characteristics that these functions have. So we're going to be talking about the domain and range, the intercepts, and the maximum or minimum of these functions. So let's first talk about the domain and range. Remember that the domain is all possible x values of a function, and the range is all possible y values. Remember that we can describe domain and range using inequality, interval, or set notation. But in this video, I'm going to focus on just using interval notation. So let's think about this square root parent function that we just graphed. Notice that the domain has a very specific starting point, right? So the lowest x value is going to be 0. So we're going to start off at 0, and since that's included, I'm going to write a square bracket. Then from 0, my graph is headed to the right. So remember that going to the right means the graph is headed to positive infinity. Okay, and whenever we write infinity, we're going to use the open parentheses, because remember, infinity is more of like an idea. It's not a specific number. Now let's think about the range. The lowest y value on this graph is also at 0. So we're going to write 0, and then we're going to use a square bracket to show that 0 is included. And from there, our graph goes up, so it's going to go up to positive infinity. So this is how you describe the domain and range of the square root parent function. So now let's think about some restrictions on the domain. Notice that when I write the domain, all real numbers are not included, right? So I didn't say that the domain goes from negative infinity to positive infinity, because notice that my graph doesn't actually include these negative x values, right? These are excluded from my domain. So let's think about why this is true. If we look at the parent function, why do we not include those negative x values? Well, let's think about what happens if I plug in a negative value for x. So for example, if I plug in -4, I get the square root of -4. Well, remember from first semester that the square root of -4 is equal to 2i. So that is actually going to be an imaginary number. Well, when we're graphing on our coordinate plane, remember that we're only graphing real numbers, right? So we only have real numbers here on our coordinate grid. So that's why we don't include values that have imaginary or complex solutions, okay? So that's why we're not including anything. And we're going to say that x is going to be greater than or equal to 0. So now let's think about the intercepts. The intercept will be points where the graph crosses the axes. So the x-intercept will be where the graph crosses the x-axis. And remember, at the x-intercept, the y-coordinate is going to be 0. The y-intercept will be where the graph crosses the y-axis. And remember, at the y-intercept, the x-coordinate will be 0. So let's look at the intercepts of the square root parent function. The square root parent function actually intersects both the x and y axis at the origin. So the x-intercept and the y-intercept are both going to be actually at 0, 0. So square root functions can have a minimum or a maximum value. So the minimum value will be at a point that has a y coordinate that's smaller than all the other points on the function. So if we look at this quadratic function in this graph, it's going to have a minimum y value at -4. Okay, so always remember we're looking at y when we're talking about maximum or minimum. So that means that we would say this function has a minimum value of -4 because that's the y value, and that occurs at x equals -3. Some functions will have a maximum value. So the maximum value will be at a y coordinate that's bigger than all the other points on the function. So if we look at this absolute value function, you can see that the biggest y value is going to be -2, and that occurs at x equals -3. So if we look at the square root parent function, since it starts off at this point and then goes up from there, it actually has a minimum at this point. Okay, so we would say it has a minimum value of 0 because that's the y coordinate at that point, and that actually occurs at x equals 0, right? Because that's the point 0, 0. So now let's look at a different square root function and let's think about its key characteristics. So I'm going to start off by graphing this function, and remember we can do this in Desmos. So we're just going to type in the function f of x equals square root, and we're going to put x plus 4. So once you type the x plus 4, you want to click outside of the square root because it's very important that -3 goes on the outside. It's going to make a big difference, and it's actually going to be an entirely different function if you put that -3 on the inside. Okay, so be very careful in how you're typing in these square root functions. Now I want to see the table, so I'm going to go up here to edit list and click on table. So the the x values that I need are not all on here, so I'm going to go ahead and type them in. So I need -4, and I also need a -3, and then we need a 0, and we also need 5. So I'm going to go ahead and just ask it to tell me those values. So now I can use this to fill in my table. So at -4, this graph will be at -3. At -3, it's at -2, 0, -1, and then 5 is at 0. If you want to do this by hand, remember you would do this by plugging in these values. So you do like -4 plus 4 minus 3, which is equal to the square root of 0 minus 3, which is equal to -3. For -3, you'd have -3 under plus 4 under the square root and then minus 3. So that's going to be the square root of 1 minus 3, which is equal to -2. If we plug in 0, we get the square root of 0 plus 4 minus 3, which is equal to the square root of 4 minus 3, which is 2 minus 3, which is -1. If we plug in 5, we get the square root of 5 plus 4 minus 3, which is equal to the square root of 9 minus 3. And remember, the square root of 9 is 3, so 3 minus 3 gives us 0. So now we can go ahead and plot these points over here. So we have -4, -3, -3, -2, 0, -1, and 5, 0. So if we connect these points, we can now form the graph of our square root function, right? So notice that it does look like the graph that we have in Desmos. So now let's think about the key characteristics of this function. So notice that the domain has a very specific starting point, right? It starts off at -4 and then it heads to the right. So the domain is going to go from -4 to positive infinity. Also notice that the lowest y value is at -3. So the range is going to go from -3, and then from there it goes up. So it's going to go up to positive infinity. The intercepts, I think the quickest way to find the intercepts is honestly to use Desmos, because if you click on them, it's just going to give you the coordinates. So notice that this has a y-intercept at 0, -1. And then for the x-intercept, we're going to go over here, and if we click on that point, it tells us the x-intercept is at 5, 0. So once again, this graph does have a lowest point, and from there it goes up. So if I go to Desmos and I click on that lowest point, I can see that it's at -4, -3. So this graph is going to have a minimum, and it has a minimum of -3, and that occurs at the point x equals -4. So now you can go ahead and pause the video and try graphing this function and describing its characteristics on your own. So you can do this one of two ways, like I showed you before. You can either do these points by hand, or you can go ahead and use Desmos and get the chart to help you out. So we have 2 square root of x plus 5, and then we have -4. So this is what the graph is supposed to look like. And then if we click here, we can get the table. I'm going to need to type in some values because it doesn't have them all on here. So I need -5, I need a -4, I need a -1, and then I also need a value of 4. Okay, so that's how we get all these points that we can use to create the graph over here. So now let's think about the key features of this function. So the domain, once again, is going to start off at -5, and then it's going to go to the right from there. So we're going to say -5 to positive infinity. The range, the lowest y value is at -4, and then from there it goes up. So it's going to go from -4 to positive infinity. The x-intercept, we can just go ahead and click on it, and that's going to be at -1, 0. The y-intercept, if we click on it, it's going to be at 0.472. So we just go ahead and write that down. It does have a minimum value, and that's going to be right here. So it's going to have a minimum of -4, and that's going to occur at x equals -5. So let's try this square root function because this is going to look a little bit different than the ones we've done. So if we go ahead and type this in, we have f of x equals -2, and then we have square root x plus 3, and then we're going to arrow out or click out of that to type -1. Okay, so make sure that -1 is on the outside. So notice that this square root function is kind of like upside down compared to the ones that we've seen before. Okay, and that's because we have that negative in front. So let's go ahead and get our table of values. So the points we need a -3. So I'm going to go ahead and type that. And then we also have 1 on here, and then we need this to be a 6. Okay, so at -3, this function is going to be at -1. At -2, it's at -3. At 1, it's at -5, and at 6, it's at -7. So let's go ahead and plot these points. So we have -3, -1, -2, -3, 1, -5, and 6, -7. And so if we go ahead and connect these points, you can see we can create the graph of this function. So now let's look at the key characteristics. So the leftmost x value is going to be at -3. So it's going to go from -3, and from there, my graph is headed to the right. So I'm going to say it's going to go to positive infinity. If we look at the range, well, that's going to be different than our previous functions, right? Because in the previous functions, we had a low point and then it went up. Well, here we have like it's starting from the bottom and then it's going up to a high point. So we have to write the range with the negative infinity first, right? Because we go lowest to highest. So if it has like no lowest point, then that, remember, means it's starting off at negative infinity and then it's going up to that y value of -1. So that -1 is going to be included. Now let's think about the intercepts. Well, since the highest y value is at -1, this graph is actually never going to cross the x-axis. Because remember, to cross the x-axis, you have to have a y-coordinate of 0. Well, if the highest y value is -1, it's never going to have a y-coordinate of 0. So there's actually no x-intercepts. We can click on the y-intercept to find its coordinates because it does have a y-intercept. And that's going to be at 0, -4.464. Okay. And since this graph is kind of like flipped the way it is, it's actually going to have a maximum value, right? So that -1 represents the highest value of the function. So it has a maximum of -1, and that's going to occur at x equals -3. So remember that square root functions have several important characteristics that we can identify by graphing in Desmos. These characteristics include the domain and range, intercepts, and maximum or minimum values.